binomial radical expressions. All the first couple of examples talk about is combining like terms. There's nothing to do in the first example to simplify it except combine like terms. Since we have like radicals, cube root x, we can combine the coefficients. 5 minus 3 is 2 cube root x. Here, if you don't have like radicals, you can't add or subtract them. Okay? Simple enough, right? Just like you were dealing with variables. The next one, you got to do a little bit more work.
But they do have, I thought they do have like radicals. Oh, never mind.
No, they had to have the same number under the square root symbol.
Oh.
So even if I had, up here, if I had 4th root of x and cube root of x, you can't combine those either. Okay, they have to be the same root and the same number under the radical. They have to be exactly alike. Here, we can't combine them yet. This is the original problem. Cannot combine them yet. You need to simplify each radical separately. How do you break down the 18?
2 and 9.
9 and 2, because 9 is a perfect square. So this right here simplifies to 18 root 2. Does everybody see that? If you don't, let me know. Okay. This one, you break up the 8 to 4 and 2, so that should simplify to 8 root 2. Everybody see that? And the last one, what's the best way to break up the 72?
8 and 9.
36.
The best way, what?
36.
36 and 2. You want to pick factors, the largest factor that's a perfect square. In this case it would be 36. 36 and 2. If you want to do 8 and 9, that's fine, but you're just going to have to do more steps at the end. 36 and 2, square root of 36 is 6. 6 times 3 is 18. 18 root 2 minus 18 root 2 is nothing, so I'm just left with 8 root 2. Question? Okay? Next example. Multiplying. When you multiply two binomials, you still FOIL. You don't do anything differently just because it has a radical with it. When we do FOIL, we do 3 times 2 to get 6, plus 12 root 5, plus 4 root 5, plus 8 root 25. Some of you may be able to skip this step because we know root 5 times root 5 is just 5. You may be able to go straight to the 40. Alright? And then just combine like terms. And make sure you write it in standard form, just like imaginary numbers, complex numbers. The I comes second. Same thing with radicals. The radical comes second. The real number comes first, then the radical. So we get 46 plus 16 root 5 as our answer. Good? All right, the next example, still foiling. Does everybody have this down?
Wait, where'd you get the 12 root 5 from?
The what? This? By doing 3 times 4 root 5. 3 times 4 is 12. The next example, we're still foiling, but we're going to foil conjugates. Do you remember what conjugates are?
Yes.
What are they? What would the conjugate of 3 plus 2 root 5 be?
3 minus 2.
3 minus 2 root 5. Alright, so what do you do when you FOIL conjugates?
It's 1.
Which part of FOIL do we not have to pay attention to?
All of it.
You don't have to pay attention to the O or the I of FOIL because those two will always cancel themselves out in conjugates. So all you have to do is multiply the first and the last. Okay? So let's look at an example of that. 2 plus root 3 and 2 minus root 3 are conjugates. So all I have to do is multiply the first and last. What's 2 times 2?
4.
4. What's root 3 times root 3?
3.
3, and 4 minus root 3, or 4 minus 3 is just 1.
Are all conjugates gonna be 1?
No.
Multiplying them.
No, because if I had, let's say, 4 plus root 3, what would I have? 16 minus 3, which would be 13.
Okay.
Okay?
Wait, what did he ask?
He asked if you would always get 1 when you multiply conjugates. The answer is no. All right? Everybody got that example down? Okay, and the last example is rationalizing denominators. Remember, you cannot have a square root in the denominator. So, to get rid of it, if you have a binomial with one of those terms being a radical, all you do is multiply by the conjugate of the denominator. So what's the conjugate of 1 minus root 5?
1 plus
1 plus root 5. So I just FOIL the top, and this is what I end up with. FOIL the bottom, and I just multiply the first, which is 1 times 1, and root 5 times root 5, which is 5. Make sure you understand how I got to that answer. Simplify the top and get 8 plus 4 root 5, and then simplify the numerator and denominator. 8 divided by negative 4 is negative 2. 4 divided by negative 4 is negative 1.
Where did you get those numbers from?
Which ones?
Eight
Here?
plus- Yeah.
3 plus 5 is 8,
Okay.
and 3 plus 1 is 4.
Why would you not add the 8 and the 4 and then divide by the 4?
Right here?
Yeah.
Because those aren't like terms.
Okay.
You could only, if you had 8 root 5, you could add them.
Can you divide it, everything by 2? Or this?
I divided everything by 4. From here to get to here. Yeah, if you reduce here, you have to reduce here. You can't just reduce part of the fraction. Okay, so make sure you don't do that. So both of these need to be divisible by this number. If it weren't, you could separate the numerator up and then just divide half of it.
What do you mean?
Okay, let me show you what I mean by that. If I had something like this, 8 plus 3 root 5 over negative 4, that would simplify to negative 2, right? Because 8 divided by negative 4 is negative 2. And you would just leave the 3 root 5 over 4. That would be your final answer. If you could only divide one of the numbers by 4.
Why would you leave the 4 there?
Because I can't divide 3 by 4.
Okay.
You can't just divide this part by 4. If you didn't put that 4 in there, that is what you would be doing. Okay?
Why'd you change 3 square root 5 to negative when you?
I just put the negative was with the 4, so I just, instead of making a plus over a negative, I just made it a minus.
But it could be. Oh, I
You
see.
could put plus 3 root 5 over negative 4 still if you wanted to. Alright. I believe that's it.
Yeah.
Let's try those 4 problems. See what you get there.
Is that our homework?
Yeah.